Very good morning to all of you. It's me Pooja Datta and welcome to my channel Cbse. This is my first lecture on YouTube. Today's topic is electrostatic. But before starting this lecture, I want to link you to the natural world. After all, we are studying physics, right? And physics itself means the study of natural phenomena of the universe. So if you are studying physics without linking yourself to the natural world, without linking yourself to the day-to-day experience of your life, then studying physics is simply a waste. This nature is made up of two things: matter and radiation. What do you mean by matter? Matter is something which is all around us, which you can see. Matter has size, it has volume. Matter has mass. Everything that we see around us is matter. Matter can apply force, it can thus work. What about radiation? Radiation is simply different from matter. We can't see radiation. Radiation has no size, no volume, no mass. It only has energy. Like I am talking with you, this sound is a radiation. This sound is an energy. It is a form of radiation. Light. This visible light is also a radiation. This radiation we will cover in some next chapter. Today we are more concerned with matter. This matter has two intrinsic properties by which it can apply force. What are these intrinsic properties? What do you mean by intrinsic property? Intrinsic property means the fundamental properties. Fundamental properties means inbuilt property. We can't further research into it. If there is matter, there has to be mass, and if there is mass, there has to be charge. Matter means it has to be charge. Sorry, if there is matter, matter has mass. You can't find any matter without mass. If there is matter, there has to be mass. Now, if there is one body, it has mass capital M, there is another body small m, then mass has the ability to apply force on this body, on this particle having mass m. It has the ability to attract this mass towards itself. Even this mass can apply force on this mass and pull it towards itself. This is the ability, this is the strength, magic of particle having mass. So this force with which mass is attracting another mass towards itself, towards its center, this force is known as gravitational force. Now what about charge? If there is mass, there will be mass. If there is matter, there has to be mass. And if there is mass, there may be charge or may not be charge. Okay, I'll explain more. Assume you all know that mass is made up of molecules. All molecules are made up of atoms, and all atoms are made up of nucleus and electrons which are revolving around the nucleus. This nucleus is made up of proton and neutron. Forget about the neutron because it is chargeless. We will concentrate more on proton and electron. If this is one atom and this is the nucleus, this proton and neutron are making the nucleus, and electrons are revolving around the nucleus. This electron is negatively charged and this proton is positively charged. Now, if any mass has positive charge equal to negative charge, then we will say that this mass or this atom is neutral. If number of protons is more than the number of electrons, then obviously positive charge is more than the negative charge. We will say that the atom is positive or positively charged. If number of electrons are more than the number of protons, then obviously the negative charge is more than the positive charge. So overall the atom will be negatively charged. So negative charge or number of electrons is more than the number of protons, that means positive charge. Then we will say that overall the atom is negatively charged. So this is the reason behind the mass has charge. A mass, sometimes we see a mass has charge, sometimes we see that mass is chargeless. Chargeless means it has charge within itself, but the positive charge and the negative charge are cancelling each other. That's why the atom as a whole is neutral, and we will say that the atom is chargeless. But inside it do possess charge. This charge, you can think about this charge in many ways. What will happen if the charge is at rest or when the charge is in motion? The charge is at rest and the charge is in motion. When the charge is at rest, then it will have some properties. It will acquire some properties. It will behave in some way. And if this same charge is in motion, it will have different properties. It will acquire different properties than that acquired when the charge was at rest. And it will work, the charge in motion will work in a different way than that when the same charge was at rest. When the charge is at rest, then we will say the charge is static. So charge is static means we will say that electrostatic. Electro means charge and static means at rest. Same way, when the charge is in motion, we will say electrodynamic. Electro means charge and dynamic means is in motion. When the charge is at rest, then it will gain certain ability or strength to produce electric field. That means when the charge is at rest, that means velocity is 0, then it can produce electric field. It can produce electric field. When the same charge is in motion, this motion can be further divided into two categories. Motion, is it moving with constant velocity, or this charge is moving with variable velocity? Variable velocity means accelerated motion. It is changing its speed, whether either it is decreasing or it is increasing. So motion can be further classified into two types: velocity is constant or velocity is variable, here acceleration is 0, here acceleration is not 0, that means there is some acceleration. When the same charge is in motion and it is moving under constant velocity, then it will have the ability to produce electric field. Obviously, charge as at rest was producing electric field, and that same charge is in motion, that means it will have the capability to produce electric field, as well as, since it is in motion, it will have the ability to produce magnetic field as well. How a charge in motion can produce magnetic field? Let me see. You say, you know, when electron moves, when electrons move, or I can say when positive charge is moving this way, or electron is moving in this direction, then current is along the direction of the positive charge. This is current. Chapter in magnetism chapter, you will study when a current is flowing in a coil, then magnetic field will also build up in this way. That means if charge is moving, then along with electric field it will produce current, and when current will be produced, automatically a magnetic field will also be produced. That means charge in motion moving with constant velocity will produce electric field, as well as, since it is in motion, it will also produce magnetic field. Now, what about when the charge is in motion but it is accelerating? Accelerating means the speed is changing. So, you know, since it is charge, it has the ability to produce electric field. Since it is moving, it will have the ability to produce magnetic field. So, what's new when the charge is accelerating? When the charge is accelerating, along with electric field and magnetic field, it will also radiate energy. Now this is quite confusing, right? I'll clear your doubt. See this. This charge is accelerating, right? Acceleration, you know this Newton's second law, F equal to ma. When there is acceleration, there will be a force linking with it. F equal to ma. Acceleration means there is some force linking with that charge. Now when there is force and there is displacement, this charge is moving, that means it is covering some distance, or I can say displacement, it is changing its position. Since it is moving, that means there has to be some displacement, and since it is accelerating charge, there has to be some force linking with this charge. So F force into displacement is work done, and work done means it is energy. That means when the charge is accelerating, it can produce energy or radiates energy. Okay, the chapter that will cover when the charge is at rest is electrostatic. Today we will deal with this chapter. This is the first chapter of class 12 physics. And then will come when the charge is in motion, that is moving with constant velocity. We will have current, electricity, alternating current, electromagnetic induction, and magnetic effect of current. We will cover all these chapters when the charge is in motion and with constant velocity, and when the charge is moving with variable velocity, that means accelerated charge, then we will cover this chapter electromagnetic waves. Our visible light, X-ray, gamma ray, all are included in electromagnetic wave. Now, type of charges. There are two types of charges. One is positive charge, another one is negative charge. Positive charge is when it is deficiency of electrons as compared to protons. Now, let me explain you this. Assume that there is one atom whose number of proton number, let the proton number be 10 and electron number will also be 10. An atom is electrically neutral, that means number of proton will be equal to the number of electron, and number of proton charge is plus 1.6 into 10 to the power minus 19, and here the number of protons is 10, so into 10. This is a total positive charge in this atom. Now number of electron is also 10 and the charge of electron is also 1.6 into 10 to the power minus 19, but the sign will be negative, that is minus 1.6 into 10 to the power minus 19. It is also 10 in number of electrons is 10, that means here the charge will also get multiplied with 10. Now consider another atom whose proton number, assume that it is 20 and electron number is also 20. So total positive charge will be plus 1.6 into 10 to the power minus 19 into 20 coulomb, and electron number will be minus 1.6 into 10 to the power minus 19 into 20 coulomb. This is clear? Okay. Now, when we are rubbing these two atoms together, what will happen? Depending on the work function of these two, work function means the minimum energy the electron require to come out of the electron, to come out of the atom. Like when these atoms acquire this thermal energy, it changes the thermal energy to kinetic energy. Now, assume that I gave 10 joule of energy. Now, this energy, assume that this energy is enough for this electron to jump out of the atom. That means its work function is minimum. And this atom's work function is more than that of the electron in this atom. This electron will jump from this atom and will come to this atom. Now what will happen? Here, since due to deficiency of one electron, the number of electron will reduce. Previously it was 10. Now it will reduce to 9. And here, since the atom from outside has jumped onto this atom, there will be excess of electron by 1. So the total charge on this atom will increase by 1.6 into 10 to the power 19, 10 to the power minus 19 coulomb. Here plus charge is 20 times since the proton number is 20, and negative charge is 21 times since now the number of electrons is 21. So this atom will have positive charge because the proton number is more, and this atom will have negative charge. since the electron number is more. So positive charge means it is the deficiency of electrons. Here there is a deficiency of electron as compared to proton. So this atom as a whole is positively charged. And negative charge means it is the excess of electrons as compared to protons. See here, the electron number is in excess by 1. So overall, here the charge of this atom will be minus 1.6 into 10 to the power minus 19 coulomb, and here the charge of this atom will be plus 1.6 into 10 to the power minus 19 coulomb. If two atoms had jumped out of this atom to that atom, in that case electron number will reduce to 8, and here the charge of this atom, that means the positive charge, will increase by 2 times. Since see, electron number is 8, proton number is 10. So the charge of this atom will increase by 1.6 into 10 to the power minus 19 coulomb into 2. And this one will also, since 2 electrons has jumped onto this atom, the electron number will become 22, and the charge, overall charge on this atom will become minus 1.6 to the power minus 19 coulomb into 2. Okay? Okay. Now, like charge repel and unlike charge attract. If this is positive charge and this is negative charge, if you bring these two atoms together, it will attract each other. And if I bring positive charge and another positive charge here, then since both the charges are similar, has the same polarity, it will repel each other. Okay, SI unit of charge is coulomb, and value of charge I already told you. For positive charge, plus 1.6 into 10 to the power minus 19 coulomb, and for negative minus 1.6 into 10 to the power minus 19 coulomb. Okay, mind it that here the proton is not moving. Here for electrification, only the electrons are responsible. Here only the electrons are jumping from here to there. The protons are fixed. Why only electron is responsible for electrification? Why not proton? Because a proton is 1837 times heavier than electron. So transferring electron is easier than transferring a single proton. This nature does those work first in which we have to spend lesser amount of energy. Like we also belong to nature. We also do the same thing. Like if you are standing, you will feel like to sit. If you are sitting, you will feel like to sleep. We always do that work in which we spend less amount of energy. Here, transferring one proton will, the atom has to do a lot more work than transferring a single electron. That's why for electrification, only electrons are responsible, not proton. Now, methods of charging. There are 3 methods of charging. Friction. Okay. Have you ever wondered, when we comb our hair on dry winter, then the hair starts sticking to the plastic comb? This is because of the accumulation of charge. When we are rubbing the comb on the hair, the electrons from the hair goes to the comb, and due to the deficiency of electron in hair, the hair become positive charged and the comb become negative charge, and due to opposite polarity they attract each other. Same example I can give you, like when we bring a plastic ruler and we rub it on our dry hair and we bring it near small bits of paper, then the small bits of paper gets attracted to that plastic ruler. The phenomenon is same. Due to friction, there is accumulation of charges. You must have observed that synthetic clothes sticks to our body. This is also due to electrostatic accumulation of charges. When we take a blanket in winter, you must have hear that crackling sound coming out of that blanket, and if this room is completely dark, you can even see small sparks. All these are due to accumulation of static charges. The method of friction is when we rub one body with another body, electrons are transferred from one body to another body. Now, the second method is electrostatic induction. What do you mean by electrostatic induction? If a charged body is brought near a metallic neutral body, like if this is one charged body, assume that it has got positive charge, and this is uncharged body. Here the charge is 0. They are not in contact. I am just bringing these two bodies just closer to one another. Then what will happen if a charged body is brought near a metallic neutral body? This is the neutral body. The charged body will attract opposite charge. Here neutral body means it has positive charge as well as negative charge. All are distributed uniformly. Now when I bring this positive charged body closer to the uncharged body or the neutral body, what will happen? These positive charge will attract all the negative charges and will repel all the positive charges. So ultimately what will happen? The negative charge will come on this side towards the charged body, and the positive charge will move away from this body. Now, as a result, one side of the neutral body becomes, this side becomes negatively charged, while the other side becomes positively charged. But as a whole, this body is still neutral. It has not gained any charge. Now how to give charge to this body? What to do? Like if this is the negative charge and this one is the positive charge on this side. Now if I join this body with the earth, then what will happen? The earth is considered a sink. The earth is considered a sink means the earth is always at a zero potential, a neutral body. The earth is always neutral. If there is any charges which is in excess, then on joining that part with the earth, what earth will do? Earth will send electrons. The earth will send electrons to that body, and all the electrons will neutralize all the positive charge. Or another way I can say, if we are joining the body with the earth, then all the positive charge will go to the earth, and will get neutralized with the electrons of the earth. Now, in the third step, remove this wire which is joined to the earth. Remove this wire, and these negative charges which was attracted by these positive charges will again uniformly distributed all over the body. Now this body which was previously uncharged, now this body become charged. Now I can help you to link this electrostatic induction with the natural world. With a simple day-to-day experience, you all have observed lightning. Lightning is due to friction and electrostatic induction. I'll explain you. Clouds are made up of tiny water molecules or tiny ice particles. Due to friction between the clouds or between the clouds and the surrounding air particles, there is an accumulation of charge due to friction, and that charges arrange themselves in such a way that the positive charge gets accumulated on the upper side of the clouds and negative charge gets accumulated on the lower side of the cloud. Now we have the earth at the bottom. This earth is neutral body. This earth is neutral. Now electrostatic, just now I taught you electrostatic induction. When a charged body is brought near an uncharged body, charges are accumulated on that body. Now, when there is excess of electrons on the cloud tries to discharge the excess of electrons. The only place to discharge is to the earth, because earth is a big sink. Any object which has excess of charge, they transfer their charge, they discharge their charge to the ground. Now, while transferring the excess amount of charge, lightning is seen. This lightning is actually the transfer of electrons from the cloud to the earth. This is seen as lightning. The third method of charging is conduction. What do you mean by conduction? If a charged body is put in contact with uncharged body, the uncharged body becomes charged due to transfer of electrons from one body to another. Let me explain you. Assume that this is one charged body which is negatively charged. Number of electrons is 10, and there is one neutral body which is neutral. Here the number of electrons, number of positive charge and number of negative charge are same. That's why this body is neutral body, that is chargeless body. As there is a barrier in between, this air is acting as a barrier, and you know that air is an insulator, so it will not allow the charges to come out of it. Now what will happen if I keep these two bodies in contact? The electron will get space, will expand itself, and some of the electrons will move to this atom. When this electron will go here, and it will neutralize this plus. When this electron will come to this body, it will neutralize this positive charge. Like this electron will neutralize this positive charge. Ultimately, what is happening, see, the number of electrons here, 1, 2, 3, 4, 5, 6, 7, has been reduced to 7. That means the charge in this body, which was previously minus 10, since it was negative minus 10, now the charge has become minus 7. And here, previously, when this body was neutral, now this body has got some charge. Here plus is 2, while minus negative charge is 1, 2, 3, 4, 5. That means in case of conduction, there is redistribution of charges. Sorry. There are 2 positive charge and 2 negative charge, so they are actually cancelling each other, and there is excess of 3 electrons. That means here the charge on this atom will be minus 3. So there is redistribution of charges. Previously this body had minus 10 charge. Now this same charge has been redistributed. Now it has got minus 7 and minus 3 has been given to this body. Now I can link this conduction with the natural world. Assume that you are walking on a carpet and you are wearing shoes. Due to the friction between the carpet and the shoes, there will be accumulation of charges on your body. Now, when you try to open, under these circumstances, when you try to open the door by touching a metal knob, what will happen? Due to conduction, all the charges, all the excess charges of on your body will try to get transferred to the metal knob, and due to flow of electrons, electric current will form and you will get electric shock. I have noted down the difference between induction and conduction. In case of induction, the inducing body neither gains nor loses charge. See here, this is the inducing body, this is the charged body, which is actually inducing charge on this uncharged body. Whatever charge it had previously, the same number of charges it has after induction. So here this inducing body is neither gained charge nor loses charge. But in case of conduction, the charged body loses some of its charges. This is the charged body. Previously it had 10 charges, 10 negative charges, but after conduction, the negative charges of the charged body has reduced to minus 7. That means 3 negative charges has gone to this uncharged body. So here the charges are redistributed, and due to redistribution, the charges on this body has reduced. Now the second one is, nature of induced charge is always opposite to that of the inducing charge. This is the inducing charge. Now we have taken the inducing charge as negative, but see, the charge that has been induced on the uncharged body is opposite to that of that inducing charge. See, they are of opposite polarity. Here it is negative, so here it is positive. If I had taken this charged body or inducing body as positive, then the neutral body would have been charged negatively. So here the charges are the induced charge are of opposite polarity. But in case of conduction, charging body is negatively charged, and after conduction even the neutral body has got same charge. That means charge of the same polarity, that is negative. If I have taken a positive charging body, then the neutral body would have got the same charge. So this is the difference between induction and conduction. Now let me note down some of the properties of charge. Charge is a scalar quantity. Scalar quantity means charges can be added by simply algebraic rule. Like this is positive charge and this is negative charge. They can be added by simply algebraic rule. But in case of mass, we add them by arithmetic rule because there is mass cannot be negative. The second one is charge is always associated with mass. Charge cannot exist without mass, though mass can exist without charge. I already told you that if there is mass, there has to be charge. But if the positive charge and the negative charge are equal in number, then they will cancel each other and the body as a whole will be neutral. So if the body has to gain charge, either the positive charge or the negative charge has to be in excess. So presence of charge itself is a convincing proof of the presence of mass, but presence of mass doesn't prove that there is charge in the body. In charging, mass of a body changes. When a body is given positive charge, its mass decreases. Giving positive charge means we are taking the electrons out of that body. So the number of positive charge, so the number of protons is increased compared to that of number of electrons in that body. That's why we say that we are giving positive charge. So we are taking away the electrons from that body. That means obviously electron has got some mass. So we are taking that amount of mass from that body to automatically the mass of that body will get decreased. And when the body is given negative charge, its mass increases. We are giving negative charge to that body. That means we are giving electrons to that body and adding something extra to the previous one. Means the electrons mass are being added to that previous atom. So obviously the mass will increase. Now the third point is charge is quantized. What do you mean by quantized? Electric charge can have only discrete values rather than any value. Like which one is the discrete value? The smallest discrete charge that can exist in nature is 1.6 into 10 to the power minus 19 coulomb. This charge is actually the charge of a single electron. Either you can take one electron or you can give one electron. So the charge in a body is always the integral multiple of these electrons. Either it has to be 1 electron or 2 electron or 3 electron. Means 1 into 1.6 into 10 to the power minus 19 coulomb. That means the integral of this value. But I can't say that I have given that body 0.5 electron. That is not possible. Either you take electrons, means 1 electron, 2 electron, 3 electrons, means in whole number you can take electron or you can give electron. But in fraction, you can't take electron or you can't give electron. So that is, charge is quantized. Charge is conserved. Charge is conserved means isolated electric charge. Isolated means single electric charge can neither be created nor be destroyed. It can only be transferred. In case of radioactive decay, you have one uranium particle whose atomic number is 92 and mass number is 238. When this uranium particle get decayed, a helium nucleus is developed and thorium is formed. Helium electronic number is 2 and mass number is 4. Thorium electronic number is 90 and mass number is 234. Thus you can see the number electronic number means atomic number of uranium was 92. That means the number of proton or the number of electron of uranium was 92. This charge has been distributed among these two. 2 has been given to helium and 90 has been given to thorium. But charges in pair can be created or destroyed. Like example, annihilation. In case of annihilation, one electron combines with one positron to form two gamma rays. This electron and positron, they in pair are destroyed since gamma rays has no charge. And another example is pair production. In platinum get react with two gamma rays and release one electron and one positron. Here there were no charge previously. Now two charges has been evolved in pair. Single charge cannot be created nor be destroyed, but in pair charge can be created, can be destroyed. Okay, next one is charges resides on the surface of a conductor. This is a conductor. Assume that I have given some charges to this conductor. What will happen in case of conductor? This is conductor and this one is insulator. I have given charges to both of them. What will happen in case of conductor? The charges has the freedom to move. That means these electrons, these charges being of the similar polarity, they will repel each other and all the charges will move to the farthest possible distance. That means they will reside on the surface of the conductor. But that is not the case in case of an insulator. This has no freedom to move. That's why charges in an insulator will be uniformly distributed over the volume. The last portion that we are left with is the difference between electric charge and mass. Electric charge can be positive, can be negative or zero. But mass is always a positive quantity. Mass can never be negative. Charges carried by a body does not depend upon the velocity of the body. Like if any particle has this number of charges and now it is at rest. Now if this same particle is moving with any velocity, then the charge will remain the same. The charge will not change. But in case of mass, that is not the case. mass of a body increases with its velocity. That means when a body is at rest, whatever mass it has, that mass is known as its rest mass. But when the body starts moving, its mass increases. But in case of a bigger body, like all the visible object, that increment in mass is very negligible. So we can ignore it. But in case of quantum physics, like that of, if we talk about electron, proton, or smaller object which is equivalent to the size of electron, then the increment is mass is quite noticeable. Like mass equal to, this is the rest mass, m is the mass of the body, and root over v is the velocity of the body, and c is the velocity of light. If one electron has a velocity like c by 2, that means half of the velocity of light. So what will happen? V equal to c by 2. Now put the value of v in here. This will be c by 2. That means c square by 4, and this c square. So c square cancelled out, and I remained with 1 by 4. So 1 by 4, this number is less than 1. So 1 minus something which is less than 1, the overall will be lesser than 1, and the square root of that number which is lesser than 1 will still be smaller than 1. Now anything like 2 divided by 0.5, 0.5 is less than 1. Any number divided by some number which is lesser than 1, ultimately the result will be greater than this numerator. That means the overall result will be more than m0. See here, the overall result, that is 4, is more than 2. Same here, the overall result will be more than the numerator, that means more than m0. So there will be some increment in mass. But this is only noticeable in case of quantum particles. All quantum particles moves with velocity which can be comparable to the velocity of light. Now, electric charge is always conserved. I showed you this in radioactive decay. Electric charge can neither be created nor be destroyed. Electric charge is always conserved. But in case of mass, mass is not conserved, as it can be changed into energy and vice versa. You know this famous equation of Einstein, E equal to mc square. Mass can be changed to energy, energy can be changed to mass. That means mass is not conserved. Forces between charges can be attractive or repulsive. Like plus and minus both attract each other, plus and minus repel each other. But in case of masses, the gravitational force due to mass is always attractive, because masses are always positive. The negative mass is not found. So students, this is all for today, and in the next lecture I'll come up with all the numericals of this topic. This is the first video on YouTube, so I don't know whether my lecture is worthwhile to you or not. So please do comment and give me feedback. Thank you.